Hey guys, it's Trafotin. Do you want to know what's something you probably don't do, but you definitely should do? Verify your downloads. Verifying downloads is something that should be ingrained to every computer user. Unfortunately, this process is very complicated, and very few services make this easy for most people. And it can be intimidating to be told to use a terminal, especially if you're on Windows and Mac OS. And what's more, most people, especially the more technically savvy, would say, why would you even bother when most programs are probably verified already? Signed applications are necessary to ensure that a file wasn't tampered with on the way to your computer. If you use a package manager like Winget, Homebrew, or the one that's in your Linux distribution, the process is often automatic, and they actually use a lot of the same methods on the back end. The problem with a lot of these signing systems is Apple's notarization process, or the cost of the certificates as a whole to Microsoft's developers. Companies like Apple will require their developers to not only own Apple hardware, they will also need to pay in order to get their developer license to go through Apple's antivirus gatekeeper thing. What's more, if you're on Microsoft, you need to pay a third-party certificate developer like DigiCert or Komodo to handle your certificate for you, and then you need to sign that certificate with another Microsoft certificate, and then you go and sign your application with your two mashed up certificates. And unfortunately, in this case, both Apple and Microsoft and the certificate authorities will charge you at least a couple $100 just to make sure the program that you made or the developer made isn't blocked by the default antivirus. Just because an application's unsigned doesn't necessarily mean that it's malware, but it's really important that we, as users, pay attention to where we got our programs from, and for developers to cough up platform fees, because that's unfortunately how security is handled automatically and the easiest for most people. But it's also important to remember that if you can't, we have to try to verify the files, and if you don't verify the files, there's often really nasty consequences. A couple years ago, Linux Mint was hacked, and their ISO was modified to mine cryptocurrency off the unlucky souls who had downloaded it. Now, thankfully, Linux Mint's team shut down the attack very quickly, but it goes to show how important it is to verify your downloads. The attack that was done against Linux Mint's users could have easily been prevented if users verified their downloads. And unfortunately, verifying downloads is something that doesn't get enough attention. The hacker of the Linux Mint forums and servers, Peace, made a very bold but very accurate claim. And that's why it's really important that we learn how to verify our files, because we're going to go and prove him wrong. I'm not going to lie to you and say this is going to be easy. It's probably really convoluted, but maybe this is something that we need to develop, or we need to develop a process that makes all of this easier for people so they don't have to deal with any of this at all. Now, one of the most popular ways to verify files is pretty good privacy keys, or PGP keys. PGP is often necessary for verifying other files using a central server of trust. What a lot of developers do is they upload certificates of files attesting that the files signed with their certificates came from them. PGP is typically handled with a command line application called GNU Privacy Guard, or GNU-PG. Wow, what a terrible name. There's also various graphical front ends for GNU-PG. So for example, if you're on Windows, there's an application called GPG for Win, and if you're on Linux, there's an application called Cleopatra, and both of these programs are very similar to each other. Now, if you are on Mac OS, there's an application called GPG Suite, and GPG Suite's slightly different, but fulfills the same functions that you would get with Cleopatra or GPG for Win on Windows and Linux. Of course, like most GNU applications, GNU-PG, or any of its front ends, like GPG for Win, GPG Suite, or Cleopatra, are not particularly straightforward to use, and this is probably a sign that someone needs to get out there and make a process for handling these certificates way easier for a lot of people. Now, I'm going to be covering how to use Cleopatra, and if you're on Windows and you're using GPG for Win, the instructions are going to be very similar, but if you're on Mac OS, you're probably going to have to click different buttons than the one that I'm going to do. Now, the first thing you're going to want to do is you want to download the files that you wish to verify. And you're going to need your desired file. And this can be like an installer file, a Linux ISO, maybe it could be like your favorite app image, and the signature file that's used to sign this application. And it's often with the extension .sig or .asc. If you're going to download OpenSUSE Tumbleweeds ISO and verify the checksums, the files that we are going to need is the signature file, which ends in .asc, and we're going to need the file that we want to verify, which is usually named something exactly the same. As well, please make sure that you note where your files are downloaded so you don't lose them and you can find them with ease. Next, what you're going to do is you're going to go to your GPG program and navigate to anything marked as decrypt or verify. First, you're going to select the signature file, and then you're going to select the file that needs to be verified itself. And if you're told a certificate is unavailable, the next thing that we're going to do is we're going to download the key from a known key server. And this is going to be a random blob of numbers that represents a certificate as a whole, so the file can be verified with the central server and with the developers. And then once the key server has found the certificate, we're going to click on it and select import. And when you import this information, the same certificate is downloaded onto your computer, and it's the same information that was originally on the key server, so you know that you have the same file. And then once you click the accept dialog, your certificate has been imported. And then if you repeat the process of decrypting or verifying your files and select the exact same files again, you get told, uh-oh, the signature could not be verified, and you need to ignore this warning. GNU PG does this because of people who try to sign messages to each other, but if you're just trying to verify the file, you don't need to have this get verified at all. And this is why GNU PG is very confusing for people who don't know how it works. And people who are trying to verify these files aren't trying to necessarily encrypt the files, they're just trying to make sure the files came from the same place, and they don't need to upload their own key to sign it because that's what it's actually asking for. Wow, that's confusing. So instead, what you want to do is you probably want to look for a command line option or a show for an audit log, and you want to look for the text good signature. And if you see good signature, that means the file has been verified with the same certificate as an authentic file. And if you see bad signature, that means the file has been tampered with in some form or fashion, and you should probably yell at somebody. Now, when it comes to verifying files, one of the other things that you might need to catch up on is checksums. Oftentimes, software makers will provide checksums, which are alphanumeric representations of files or data, and every single file has one. There's a lot of different algorithms to check the integrity of files. It can be something like SHA or MD5, but it's different for every operating system. Linux happens to have the most comprehensive and commonly used hash verification tools, which are developed also by the GNU project. The commands also have a built-in checker to check formatted checksums in a file. All you need to do is type out the specific algorithm that you want to use, then sum. So for example, if you want to check the SHA-1 sum of a project, all you have to do is you do SHA-1 sum and then location of your file. Now, if typing the file is too difficult, what you can do is you can drag the file from your graphic file manager into your terminal, and then it will immediately place the file where it needs to go. And this is true on Windows, Mac, and Linux, so you don't have to worry about typing in the file or getting it correct. The next thing to be on the lookout for is when you download your file is to be on the lookout for a file which contains SHA-256 sums, or it might be on the website itself. And if you want to check the checksum, the output of the file, which is the very first thing that you'll see, should be the same exact letters and numbers as the one that appears on the website. If you're given an additional file to verify the checksums, what you can do is you can do MD5 sum-C. You can also do the same thing with SHA-256 sums, and it will automatically verify your file for you. Now, on macOS, it's a little different because macOS avoids using the GNU versions of these tools. So instead of typing in SHA-256 sum, you would instead do SHA-sum-A256. So it's the same idea, but it's a little different. And the same is true of MD5, so you would do MD5 and then location of your file instead. And if you're on Windows, Windows uses a utility in PowerShell called get-filehash, and it's a catch-all command for all encryption algorithms. Since PowerShell isn't Unix-like, like macOS or Linux, it's going to be a little different. So if you do get-filehash, and then you put in the location of your file, then do -A algorithm, and then followed by the algorithm that you want to use. This can be MD5, SHA-1, SHA-256, SHA-512. Most common algorithms are supported on Windows. But regardless on operating systems, you verified your PGP key, you've checked your file to make sure that everything's correct. Congratulations! Now your file is ready to be used. And now that you know to verify your files every time, you can keep yourself safe from the nasty things out there. The only thing that we need to do now is develop tooling to make all of this a lot less painful for people so they don't have to go through all of this in agony. Why don't you go leave a like on this video? Leave a like on this video if you're tired, just like the poor developers who have to pay Windows and macOS boatloads of money just so they can get all of their software notarized. Also, if you're interested, all of this is available in a transcript on my website, as well as some nice handy dandy sample terminal commands that you can use for this whole thing if you don't want to use a GUI. If you're willing to donate me money, you can give me money through Patreon or through YouTube memberships. And thank you for all the people who are giving. What you're really doing is you're helping me pay for the ridiculous fees that keep my website up and running. So thank you for watching. I will see you guys next time, and have a great rest of your week.